Dear all, thanks a lot for joining to this exhibitor talk panel that we are having here. And during this talk panel, this discussion, we would like to talk about a certain topic, which is, to my understanding, a very important one while handling and talking about pharmaceutical manufacturing systems or food and beverage production systems. The topic here is cleanability. In other words, what is related to this as well is cleanliness and cleaning as well. So these three topics are basically totally different, because cleanability means how well is a system to be cleaned. Cleaning certainly means the active part in that, and cleanliness means how clean is the surface after the cleaning effort at the end of the day. In order to make a brighter approach here, a wider approach, we are here a group of people having different kinds of experiences. I invited for this talk panel our colleagues, very experienced colleagues from Calamo, which are part of the Dockweiler group. This is Henrik Ullstein. Henrik, are you with us?
Yes, I'm here.
Great, good to see you. And we have invited here also Markus' team. Markus, you're with us as well?
Yes, I am. Hello to everybody.
So among our three, we would like to discuss this topic. And I would like to ask first, Henrik, can you introduce a bit the scope that we can provide at Calamo? What kind of services regarding cleanliness or cleanability or certainly cleaning as well does Calamo provide?
Yeah. First of all, we are working with electropolishing of stainless steel. And when you electropolish the surface, it gets much smoother and then it's easier to clean. We also work with pickling of stainless steel. After welding, it's very important that you remove this welding oxide to keep it clean. We are also working with cleaning with highly purified water after all our treatments to make sure that the surface is completely clean when it comes to our customers. We are also doing some passivation, anodization, and other kinds of acid cleanings of stainless steel.
Okay. So thanks a lot for this, let's say, first glance of services Calamo is providing. I think we will go later on into a bit more detail as well. So Markus, please let us know a bit about your experience, where you're coming from.
Yes, I'm a brewmaster, so a very specialized man in biotechnologies. I was working for several companies for many years, like process online measurement instruments or hygienic processes.
All right, thank you. Okay, so I believe we have a very experienced group of people here that would be able to discuss this topic in detail. And I think the initial question is that we are all starting from the same basic material. So we certainly start, while talking about stainless steel surfaces, from probably either a cold drawn material or a cold rolled strip material when we're talking about, for example, tubing. And this tubing later on is manufactured the way that cold rolled strip, for example, receives a longitudinal weld seam, and then we have a basic tubing with a cold rolled strip material, which is already quite well in surface finish. However, this usually gets further treatment. And the question is, how can it be treated? On the one hand, we are certainly able to mechanical polish that material. On the other hand, we can certainly start pickling, we can start electropolishing it. So, Henrik, with regard to this treatment processes, what would you, or how would you consider, from your point of view, the properties of each treatment step?
Yeah, the pickling of a tube, it cleans it. It takes away if it's any foreign oxides or iron on the surface of the pipe or the tube. But it makes new oxide that is pure, but it's still kind of soft. So if you want to have a better surface on the tube, you need to electropolish. And if you electropolish, you get a very smooth surface that's easy to clean with a very hard and durable oxide on the surface.
Okay. You mentioned before that it was very important to remove also oxides and discoloration when you are welding certain components, tubing, fittings to each other. So could you please explain to us why this is important, why this makes a difference in the, let's say, downstream processes once the system is in use?
Yeah, there's several reasons for take away the welding oxide. First of all, you need to protect it for corrosion. If you have the welding oxide left, it's very easy for the corrosion to start underneath the oxide. So you need to remove that, and you need to create a new oxide that protects all the material in the same way. Also, when you do a welding, you will transform some of the austenitic material to a ferritic material that also corrodes easier. And for the last part, you need a more smooth surface to be able to clean it. That's also a point why you should treat the welds before using them.
Okay, thank you. Markus, what kind of, let's say, requirements do you experience from your time in the pharmaceutical and food and beverage industry? What kind of, let's say, treatments or standard requirements do exist from a, let's say, system owner's point of view?
Yeah, this strongly depends on the branch we are talking about. Food industry normally requests roughnesses of lower than 0.8 micrometers. Standard request for pharmaceutical processes is lower than 0.4 micrometers. But that is, from my point of view, mainly, well, an experience that people always used these kind of roughnesses. I can probably later on go a little bit deeper in is it necessary to have these roughnesses or is it not? That's quite an interesting topic where many or some scientists were working on. The main reason for these surface treatments is, of course, you said it already, cleanability. Cleaning is a major topic in pharmaceutical as well as food and beverage industry. It means product safety, and of course reduction of cleaning time means savings and more production time. So we have both these topics. Clean it longer means more safety, clean it less long means savings and more production time. So cleanability of the system, depending on the surface you choose, is very important if you have a new production system.
Okay, thank you. But what kind of, let's say, surface is recommended, or what kind of surfaces is most of the time or most of what you are aware about in use? As we know, we can use bright annealed surfaces.
Yep.
We can use grinded or mechanically polished material. Certainly the, let's say the RA value can be very good, but is that the full story or what is behind?
Well, yes, as I mentioned before, my feeling is so the mostly requested surface quality is just requested by roughness. So nobody is, or often people are not talking about topography or surface treatment. So sometimes people just request a roughness of 0.4 micrometers for pharmaceutical equipment, but well, they don't really ask for is it grinded or is it electropolished or whatever. So often people don't take care of this part. How do you reach this surface quality in terms of roughness only? As I said, pharmaceutical industries mostly just request 0.4, and in food and beverage 0.8 is very often used, or it's mainly.
All right, thank you. Hendrik, from your perspective with regard to the services you're providing, do you have an idea on the cleanability of different surfaces? I mean, and you were mentioning this as well, you were mentioning the electropolished surface, the pickled surface. Probably certainly you're aware about mechanically polished surfaces as well. So from your perspective, what provides the best, let's say, cleaning behavior?
I think that electropolish surface is the best if you look at the cleanability, because even if you have the same roughness on the mechanical polished surface compared to electropolished surface, the electropolished surface is much smoother. Even though you have the same amplitude at the surface, it's more wavy than a rough mechanical polished surface where it tends to stick more to the surface.
Okay. Would you say that this depends also on the type of contamination which is on the surface? So please let us a little bit more know to which, let's say, applications you are serving electropolishing. Is it more to semiconductor or is it more to pharmaceutical related applications? What is your let's say your focus?
We have all the different areas you're talking about, but of course medical and pharmacy is growing, more and more vessels for that industry, and for electronics, the semiconductor industry needs to have very, very smooth surface. But we have also the paper and pulp industry, which is quite interesting because they don't want the pulp to get stuck in the pipe on the surface. So they think it's very, very important to have electropolished surfaces because the cellulose fiber tends to stick to a surface otherwise. But we also have nuclear industry and some automotive industry. But yeah, I would say that the biggest one is the medical, and the food industry is growing. So more and more food companies understand how important it is to have these good electropolished surfaces.
Okay. Well, thanks a lot for this so far. And what we've done is we brought also some samples here with us that we can certainly talk about. For example, we are having something like this, which is a zip lens, which is usually used in pharmaceutical applications. So it's a clean in place device. And Markus, I believe you're pretty familiar with something like this as well. So how is it used and where is something like this usually being used?
Yeah, it's a good question. Well, those CIP lenses are mostly used, for example, in lyophilization units. So a certain difference between many CIP lines is normally you have a product inside a tube, you do the CIP inside the tubings. A CIP lens is built inside a production chamber, and it has to be cleaned from the outside too. So therefore you do some electropolishing to the outside, which is not typical. Normally you do electropolishing of tubes on the inside because you have product wetted part is the inside of a tube. In that special case we can also provide electropolishing of the outer surface. So if you have some products that stick to the outer surface of the CIP lens, it can be easily cleaned here.
Right. Thank you. Another let's say sample is that I have here in my hand, and as you can probably see very well, this sample is electropolished on the inside. And the question is certainly how would be the cleaning effort? You can see that it has a rather, let's say, complicated inner structure. And as we have this in electropolished, what would be the cleaning purposes of something like that? Or let's say the cleaning options that we actually have. If this would be contaminated, how would be the cleaning options? I mean, we can certainly just guess about it. Yeah, we certainly don't know, as this is certainly a sample here. But what would be your opinion, Markus, if you have a look at it, and how would you consider the cleaning possibilities that we would have if this would be, let's say, if this would have a surface which is not that good to clean compared to electropolished?
So the problem that you might have here while cleaning is you have certain parts that just stick into the product line, and you might have some current shadows in here. So if you do a cleaning, there are some places inside the tubing where you don't have a high speed of your cleaning detergent. If you can reduce the forces of your contamination sticking to the surfaces, you can still have a good cleanability of your tubings or of your system, even in places where you have current shadows, just by reducing the forces between contamination and surface of these product wetted parts.
So something like that then certainly should be electropolished. So the more complex the structure is, the more or the even better the surface needs to be in order to make it, or to have a less cleaning effort, or to make it cleanable at all. Is that true?
Well, as always, it's not only black and white. There are some parts of gray in between. It strongly depends not only on the surface, it's always a combination of the complete system. What kind of contamination do you have? What kind of cleaning detergent you have, or cleaning program, temperatures, and so on. And of course, the cleaned surface and the cleanability of the surface itself. Let's take, for example, in the last times, biotechnology is a very big growing part in pharmaceutical industries. And in biotechnological systems, you often have the problem of biofilms. And biofilms are a strong adhesive contamination. And if you really have to remove something like a biofilm, there is really a significant impact of the roughness on cleaning time. So if you do a diffusive cleaning, for example, you have some products that are easily dissolved by the detergent. Surface is not as important, but if you have contaminations that really stick to the surface, then an electropolished smooth surface with a low roughness really has an impact on cleanability and on cleaning time, and will create a lot of savings and product safety here.
Okay, thank you. Taking into consideration this part here again, I wonder, Hendrik, if something like that, I mean, as you can see, it's probably rather complex here, but if you consider something like that, which is certainly quite complex geometry, and therefore I believe also quite expensive to manufacture, and if you consider you have other parts in your system that might be as complex as this as well, and you have a certain contamination, would it be an option to use any of the cleaning methods that you mentioned in the beginning, also to use them in order to, let's say, optimize the structure again, or the surface again? So let's say you have a contamination and you want to get rid of it. What would be the best method to do so?
It's a hard question because it depends a lot of what the object is and what is inside it. What is the residues on the surface? But you can of course start all over again and clean it as much as you can, and take about the fatty acids from the surface, and then pickle it in hot pickling. And you can always do a new electropolishing of a material and have it fine as new again.
So you would say that a re-electropolishing of a surface will result in a condition which is as good as the primary electropolishing?
Yeah, you maybe have to do a mechanical polishing too inside, depending if it's corroded or if you have any other pitting or something inside it that you maybe have to remove. But or else it should be possible, and there is customers that send old equipment back to us for electropolishing, and it makes them more or less the same as new again.
Okay. Coming back to a comparison between mechanical polished and electropolished, I believe the surface structure, or let's say the topography of these two systems are completely different. Markus, from your point of view, how different is that actually? Or let's say compare it by a normation of size of the surface. If we have like 1 square meter in an electropolished. So Markus, what would you say from your perspective? Yeah. What would be the difference in surface from an electropolished version to a mechanical polished version?
Yeah, it sounds quite strange, but if you really compare a mechanically polished surface and an electropolished surface, there is a factor of approximately 8 times the same surface. So if you have 1 square meter of electropolished metal, it will be a real surface of approximately 8 square meters of mechanically polished surface. So it really has an impact. And as you already said, we are talking about cleanability. So you can see that you have a real big surface where any kind of production contamination can stick to, which increases the force of the contamination that sticks to the surface. So that means it makes it much harder to clean it off, to peel it off by a cleaning detergent. So the smoother the surface, the smaller it is, and therefore it means it is much easier to clean it off.
Okay, thank you. So, but both conditions, let's say it this way. Hendrik, I don't know if you have experience with that as well. So both conditions, be it either mechanical polished or be it either electropolished, both conditions may have the same RA value, right? I mean, the RA value is something that more or less everybody is using globally in order to define the surface. But the question is that enough? Or shall we also take the topography more into account, say how smooth is the surface? Because we all know that an RA surface, let's say of 0.5, can be established by certain different geometries and topographies. So how would you consider this? How would you consider the cleanliness finally here?
Yeah. There is a huge difference in cleanliness between a mechanical polished surface and electropolished, because I mean, it's like in the spring when the farmers had put the plow in the ground, that's a mechanical grinded surface, and the electropolished is when the grass is green on it. I mean, that's more or less the difference between a mechanical polished surface and a electropolished. So it's a huge difference in how rough the surface is if you get it in a microscope.
All right, thank you. So from your perspective, Markus, is there any also kind of scientific evidence on which cleanliness or what surface structure is the best one to achieve the best cleaning behavior?
Okay. Yeah, well, that's not, there's not one real solution. It strongly depends on the kind of contamination you have. For example, if you have just particles, or so it's a minor contamination, only particles like well, yeast cells or whatever you might have in there, it is not the roughness at all that is mainly important. So the impact of roughness is not as big as the impact of topography. So if you have in your topography a mechanically polished surface, for example, you mostly have some rough spikes, really rough peaks, and those might act like claws that hold on to cells. But if you have a smooth and well, let's say flash electro polished surface, it rounds up the peaks, and those cells might not stick as good as on these rough mechanically treated peaks. For example, as I mentioned before, if you really have biofilms or thermofouling or anything like that that really stick to a surface, it is important to have the surface smoothened as much as possible and really cleaned it down to a lower roughness by electropolishing, because there is really a significant impact, as I mentioned before, for cleaning of these films, fouling, biofilms, anything like that, really stick to these rough surfaces and can be cleaned easily off electropolished surfaces.
Okay. Thank you. Well, I think we're almost done with our time, and I hope we made it quite clear that the surface treatment in a pharmaceutical system matters a lot. Not only with regard to the total cost of operation, when you think that probably a hourly revenue in the pharma industry can be 5,000 to 50,000 euro, depending on the application. So it matters certainly as well to the final product quality you would like to achieve. However, as we just have half an hour, we would like to thanks a lot for your time. We hope we could make this idea of surface optimization and options that you have in the pharmaceutical or process industry in general. We hope that we could make this a little bit more clearer, and we would certainly be very open for your question. Again, from Neustadt Kleve, thanks so much, take care and stay healthy.
Bye-bye.